So I think I need to recalibrate my smartboard quickly. It looks like it's slightly off. Sorry about this for the beginning of the recording. So our quiz is tomorrow. Remember, it is on complex numbers. We should have 4 questions on that, and then 3 questions on rational functions. So if I click on the quiz review here, takes me there. Okay, it's taking me to this screen. So that's telling me some people are already in progress, which is awesome. Remember, with the quiz review, I do give you guys 20 attempts. I've never had a student take that many attempts, but hey, if you don't like how you did the first time, you can try it again to see how you would do. So let's start a new attempt and work on this together. Okay, so this first one, really not too much to this. This is just a matter of adding complex numbers. Remember, when we're adding complex numbers, it's the idea of combining like terms. So I have, let me pull up my Smart Notebook file. Number 1, 5 plus 2i plus a negative 7 minus 5i. So all I'm going to do, combine my terms here. The 5 and the minus 7 combine to give me a negative 2. The 2i minus 5i will give me negative 3i. That's it. Really not much work to show on this. If you wanted to take the time to write it out like this or type it out like that, that's fine. I'm also just cool with the final answer, honestly, with how simple this is, of negative 2 minus 3i. Please do not forget the I on this. I think if you go to the fancy math text, oh no, it doesn't have an I in there. That's okay. Just use the I off the keyboard. I know what it means. This one is subtracting. Again, I'll take the time to write it out with distributing that negative sign. If you're going to say, it's easy to do, I don't need to do that. That's not a big deal at all, okay? I will make sure to export these notes for us to have as well. So here, 4 plus 4i minus the quantity 7 minus 6i. Distribute the negative sign. 4 plus 4i minus 7 plus 6i. Combine our like terms. Life's not too hard here. 4 minus 7, negative 3. 4i plus 6i, 10i. Again, on all the questions, in case you're writing out your work, or you just want to take pictures and upload it. I know some of you are very much a fan of doing that. I do have the picture option here for all of them. So you can do your work that way and just upload your pictures. That's fine by me. So it was negative 3 plus 10i. Whoop. Negative 3. There we go. And next. This one we're going to have to FOIL out. Not too long of a process. This is one, again, we probably could get away without showing work, but I'd still really recommend you do in case you make a mistake. I'm not seeing you guys make a lot of mistakes around I squared being negative 1, but that is a common mistake students make. So if you mess that up, but you show me your work, I can give you some partial credit there. So 3 times 6, 18. 3 times negative 5i, negative 15i. Now I'm going to do the 2i. That's going to be plus 12i. And then remember the last piece here, that's going to be a negative 10I squared. So remember, I squared equals negative 1. So this is actually negative 10 times negative 1. So this actually becomes a plus 10. 18 plus 10 is 28. Negative 15 plus 12 is negative 3I. So if you messed up that I squared part, if you took the time to show me your work, if you mess up from your I squared down to here, I could give you that partial credit. But if you just give me the final answer and it's off, again, I can't find that partial credit as easily if like I can't see it. So 28 minus 3I. Again, I'm not doing the full picture upload with this just for time's sake. Oh, I forgot to add that. So let me leave a note for myself right now. Number 3 needs the picture upload. Number 3, picture. Okay. Oh, and number 4. Did I forget that? Okay. I did not forget it on those. I definitely need it for there. Okay. This one we have to rationalize. This one, I really need to see your work on it because it's just easy to make a mistake here. Remember, we need our complex conjugate. So the complex conjugate just says whatever's in the denominator, if it has a plus in it, change the plus to a minus. If it has a minus, change it to a plus. So for this one, we get 7 plus 2I over 2 plus 3I. I want to multiply both numerator and denominator by 2 minus 3I. And multiply the numerator by the same thing. So now it's just a matter of doing the FOIL on all of this. So the numerator, 7 times 2, that's 14. 7 times 3I will be minus 21I. 2I times 2 will be plus 4I. And 2I times negative 3I will be negative 6I squared. Remember that I squared becomes negative 1. And now that's all over. 2 times 2 is 4. 2 times negative 3I, negative 6I. Positive 3I times 2I will be a plus 6I. Those conveniently cancel. That's the whole point of this. 3I times negative 3I will be a negative 9I squared. So as I squared, this actually becomes a plus 6. This one actually becomes a plus 9. So now it's just a matter of combining. 14 plus 6 will be 20. And then I have negative 21 plus 4. Let's see, that should give me negative 17I over 4 plus 9 is 13. So here with this, there are 2 ways to write it. You can put parentheses like this and make it one big fraction, or I've seen many of you are liking to do it this way, write it as like 2 different fractions. It really doesn't matter. You could write it as 20 over 13 plus, not plus, it's minus, sorry, minus 17 over 13I. I don't care which way you like to write it. when we had exit tickets on this, I saw I think close to a 50-50 split of whichever way you want to write it. So I don't care which way you do it. So let's, that is, I like writing it as one fraction. So that was 20 minus 17i, all in the numerator, divided by 13. You like writing it as two fractions? It really doesn't matter. Okay. Now here's our graphing ones. With these, please make sure if it does not have a certain asymptote or hole, please say none. So if we don't find a hole in here, we're just going to say none. If it doesn't have a slant asymptote, just say like SA, none. And then we do want to graph it. I don't care if you sketch the graph or do the graph on Desmos. However, if you do the graph on Desmos, I must see the asymptotes graphed with it. Most of you, for the homework, I've seen a lot of hand sketching, and actually I've seen a lot of really good hand sketching. I do want to stress that. This year is probably one of the best years I've seen with students not crossing asymptotes when they graph, so that's awesome. If you want a hand sketch, you can upload your hand sketch. If you're like, I get it with Desmos, I can put my asymptotes on there, just so the asymptotes are in Desmos, we're good. So let's get going with this. I'm going to do it by hand and then quickly put it together with Desmos. So this is number 5. It says x plus 4 over x squared minus 2x minus 24. So right away, I do see this is factorable. So I'm going to factor the denominator. So I'm looking for numbers that multiply to give me 24 and add to give me -2. So that will end up being x minus 6 times x plus 4. What I notice here is x plus 4s will cancel, right? So remember, that says there is a hole when x plus 4 equals 0. So I do have a hole at x equals -4. That's because this will reduce to 1 over x minus 6. So my vertical asymptote will happen when the new denominator is 0. So that's at x minus 6 equals 0. Add 6. X equals 6. Last one I need is the horizontal. The denominator has a higher power, so that just defaults my horizontal asymptote to y equals 0 or the x-axis. So that is just y equals 0. Now I'm going to take this information and use it to help me graph. Some of you I know were actually doing one step further than I was, and you were taking points to test, and that's absolutely great that you're doing that. And if you wish to do it that way, you absolutely can. If you want to shortcut that and say, I'm just going to accurately plot my asymptotes and then just look at it on a graph, that's fine as well. Well, I need to go all the way to 6 here. 1, 2, 3, 4, 5, 6. Okay. So my vertical asymptote is at x equals 6. 1, 2, 3, 4, 5, 6. So I'm just going to draw a dashed line here. And my horizontal is the x-axis. If Look, I get you guys. I had different colors. It becomes obvious where that is. Give me 1 second on that question. Look, if your asymptote is like y equals 0, and you don't want to draw your dashed line over the x-axis, not a big deal at all. So where did I get my horizontal asymptote from? Again, I looked at the powers here. This is a linear equation in the numerator. In the denominator, I have a quadratic. So since the denominator has a higher power, it just defaults to y equals 0. Whenever the denominator is a higher power, it's just automatically going to be y equals 0. There's really no calculation needed. So great question. Thank you for bringing that to my attention. So let's see where this goes. Don't forget at -4, we're going to have to draw or make a hole there. So let's see here. This was x plus 4 over x squared minus 2x minus 24. Okay, so it looks like I'm in the lower left and upper right. So I'm just going to draw it in those spots. But at -4, 1, 2, 3, 4, I just know I have a hole there. It's going to be something like this, and then something like this. Again, if I was doing this for the quiz, I would honestly just take a picture of all this and upload the picture. If you just want to upload the picture of the graph and type in whole vertical asymptote, horizontal asymptote, that's fine. But right now, for time's sake, I'm just not going to take the time to upload it. Remember, if we were doing it on Desmos, we would have to say y equals 0, put that horizontal in. Please remember, I like to see those as dashed, so hit your gear, hit here, and change it to a dashed line. And then my vertical was x equals 6. So if we're doing it on Desmos, I need to see those asymptotes in there. Desmos doesn't show us the hole right away. So that's where you're going to have to just identify it through text by saying basically, again, we can use this abbreviations I've been using all week, that our horizontal asymptote is y equals 0. Then ask for the vertical. That was x equals -6, or not -6, +6. And then I did have, did ask for slant asymptote. My slant asymptote would be none. And then my whole x equals -4. And then upload a picture of it as well. I don't care if it's a Desmos picture or a hand sketch. Next one. -25, 10 plus 25. Okay. Whoop. Come on. Number 6. So this says x squared minus 25 over x squared, I think it was minus 10. No, plus 10. Plus 25. Both numerator and denominator can be factored here. The numerator will factor to x plus 5 times x minus 5. because 5 times -5 gives me that -25 on the end. There is no middle x term because a negative 5x and a positive 5x cancel out with each other. The denominator, well, if I need 10 in the middle, I can just make them both plus 5s. So something very interesting is happening here. For this, yeah, these will cancel out. But it's actually not going to create a hole, because the hole and the asymptote will be at the same spot. If you list it as a hole and an asymptote, I'm honestly not going to be that upset about it. But here, technically, this will not be a hole just because there's already an asymptote there. So if there's an asymptote, we already have our gap. We don't need to call it a hole as well. So here with this for my vertical asymptote. That's just going to be x plus 5 equals 0. I get x equals -5. Okay, that's where my vertical is. Now my horizontal asymptote, what I want to do is look at these. These are the same power. Actually, sorry, no, let me go back to the original. It really doesn't matter if you're looking at the original or the reduced, but I'll go all the way back to the original just in case there was an error in there. X squared and x squared, they're the same power, right? So I can look at it and think of this as y is equal to x squared divided by x squared. Well, x squared divided by x squared, that's just 1. That's my horizontal asymptote. So here with this, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5, 6, 1, 2, 2, 3, 4, 5, 6. Okay. So x equals -5. I had a vertical asymptote. 2, 3, 4, 5. So I put my dashed line there. My horizontal is at 1. Put my dashed line there. And now, again, some of you were like, oh, I could maybe try -6 to get a point. I could try -4 to get a point and just see which sides it lies on, which basically new quadrants. But I'm just going to take the time to type it into Desmos to see where that lies. And again, confirm that this one ends up being a little strange with the hole and the asymptote being the same, but it's okay. And then the denominator should say x squared plus 10x plus 25. Okay. So yeah, see, this is doing something really weird here at -5. So actually, it's kind of already giving me, oh, when I zoomed out, it stopped doing it. Because it's both a hole and an asymptote, sometimes it can get a little glitchy there, but that's what's happening here. You notice I can't click on it like I can click on other parts. So let's readjust these asymptotes to y equals 1. Okay, that looks good. And then this one to x equals -5. So again, as I zoom out, there we go. So I get it up in this quadrant and down in this quadrant. So I want to be upper left and lower right. So upper left and then lower right. And like I said, I do want to applaud you guys. You guys are doing a great job. Those that have already handed in this homework that I've seen, great job not crossing your asymptotes. That's usually something that bugs me every time I do this. I'm like, you took the time to graph that part neatly, and then you got sloppy with your drawing of the curves. You guys are doing an excellent job with that. I do want to applaud that. Okay, one more question. Again, I'm not going to take the time because I know the time is running a little short to type that all in here. But again, you can use the, oh, that one needs upload a picture as well. Sorry about that. That will be fixed on the test, I promise. I sworn I had double checked all these. And number 7 as well. Okay, I'm really sorry about that. I will get those all fixed right after we do number 7 together. Number 7, the numerator has a higher power. Yeah, this one has a slant asymptote because it has a higher power. The previous 2 did not have any slant asymptotes, so we just say none. This one, however, does have a slant asymptote because I have a quadratic in the numerator and a linear in the denominator. So let's go ahead. We'll do our synthetic division to find our slant. Set the denominator equal to 0 to find our vertical asymptote, and then just check it in Desmos to see where it should be graphed. Okay, final question. This was number 7. This was 2x squared minus 3x plus 4 over x, I think I said minus 3. So this will have a slant asymptote. And I'm just going to do 3 goes into 2x squared, 3, negative 3, and 4. So bring down the 2. 3 times 2 is 6. 3 minus 6 is a positive 3. 3 times 3 is 9. Technically, this has a remainder of 13, but I don't need to worry about the remainder. So I'm just going to say y equals 2x plus 3. That's it. Y equals 2x plus 3. That's my slant asymptote. Never worry about the remainder when we're talking about the slant asymptote. We already basically examined y, so I'm not going to get into that again. Remember, we just care about basically the linear equation. For my vertical asymptote, I have x minus 3 equals 0, add 3, x equals positive 3. So please try your best to accurately graph this slant asymptote. That is critical to have accuracy on this. Not that I'm not saying I'm seeing a lot of inaccurate things from you. I just know when it's vertical and horizontal, it's super easy to be, oh, it's a horizontal line. It's accurate. It goes through the right number. A linear equation, there's just a touch more to get our accuracy on it. So I'm at positive 3. I go up 2 over 3. I could reverse that if I wish. I could even go down 2 and, or sorry, up 2 over 1. I think I said up 2 over 3. Or I could go down 2 and left 1 if I wish. So that should look something like so. And then at x equals 3, that's going to be way up here. So that tells me I probably want to expand this out just a little bit. Expand this up a little bit. And now I just see where it's located. Do I have my two little acute slivers, or do I have my two big, like, obtuse angles? So I'm just going to use Desmos to tell me. So this was 2x squared minus 3x plus 4, and then the denominator. Whoop, thank you. Good catch. X minus 3. So, okay, it appears it's my two acute ones. Again, I want to check my asymptotes. So 2x plus 3. Yep, that's looking good. If I change this to an x equals 3. Yeah, I want to zoom out a little bit on this. But this is my general shape. My hand sketch is going to be a little inaccurate because I see here, like, this point is 5.5, comma, like, almost 20. So yeah, that's just going to be, we'll call our sketch good enough going like this and going like this. Yes, I know this point's supposed to be like way up higher, but it's okay. It's a rough sketch to understand the shape of the graph. You know, the asymptotes are giving us our accuracy there. Again, I'm not going to take the time to type it out and all that, but I will make sure those small issues that I saw are fixed for the test and the review. If you've already tried the review and you want to go back and try a second attempt, I'd say by 8:20, all of those should be fixed so you can upload on a new attempt. And this will be uploaded as a PDF as well. So thank you guys for being here. Stop recording.